Hello, I'm teacher Ivan. I welcome you to our second lesson of motion under gravity. We looked at the first kind of motion under gravity, that was vertical motion. In today's video, we shall be looking at the second kind of motion under gravity, which is projectile motion. Projectile motion is defined as the motion of a body which, after being given an initial velocity, moves under the influence of gravity. When a policeman fires a bullet, he stops on giving it an initial speed with which it moves with. But what happens to the bullet where it stops is due to gravity. So that kind of motion of the bullet fired or a stone thrown is what we call projectile motion. So terms used in projectile motion are: we have velocity, which has horizontal and vertical component. We have displacement, still with the horizontal and the vertical component. We have maximum or greatest height attained by the object. We have time to reach the height, the maximum height. We have time of flight. We have range, maximum range, and lastly the equation of the trajectory. So we shall be deriving the mathematical formula for the above terms. We shall consider a ball projected at point O with an initial velocity u at an angle theta to the horizontal. This is what we mean. We have our ball projected with a velocity u at an angle theta, and then this one describes a trajectory until it comes back. So we shall be interested in finding the velocity at any time and its direction to the horizontal. So let us start with finding the velocity at any time. When finding the velocity at any time, we saw that at any time we have two components of velocity. We have the horizontal component and the vertical component. What causes the two components of velocity? This is it. When we come back to our diagram, velocity is acting at an angle. So since it is acting at an angle, it's not purely horizontal, neither purely vertical, but it has a horizontal component, which is u cos theta when we resolve using SOHCAHTOA. Then the vertical component of velocity will be u sin theta. So if we are to get the velocity at any point and any time, then we shall have to get the two components, the horizontal and the vertical. So that's why we have horizontally Vx equals to ux plus at. But ux is seen as u cos theta when we resolve, and the acceleration horizontally is 0 simply because the body moves with constant velocity horizontally, and therefore our Vx is u cos theta since a is 0. Then vertically, Vy is uy plus at, but uy, when we resolve, we got u sin theta, and a is negative g simply because the body is opposing gravity. And therefore, when we substitute, we shall get Vy as u sin theta minus gt. And now, if we are to get velocity at any time, we shall simply get the velocity as the square root of Vy squared plus Vx squared. And its direction is also given by the arctan of Vy over Vx, and this is acting to the horizontal. So That's how we get velocity and its direction at any time t. Then we also look at how we get greatest or maximum height reached by the body. Assuming this is the greatest height, which we are calling S maximum. At this point, our final velocity is 0. And therefore, for vertical motion at maximum height, the final velocity v equals to 0, because at that point, the body is believed to be momentarily at rest, or it is believed to be at rest before it comes back. So we cannot use the second equation to attain S, since we don't know time at that point. Therefore, the best equation to use is the third equation, where we have V as a 0, we have U, we have G, and we want S. So, since it is vertical height, we shall consider U. Why? Because we consider the vertical component of the velocity, which is U sine theta, and the V there is 0. Since the maximum height, the final velocity is 0. So when we are substituting, we must take care. V is 0, and the U is the y component, or the vertical component of the velocity, so that is U sine theta. Then it is squared minus 2g S max. It is x S max that we want, so we shall make it the subject, whereby S max, or the greatest height, is given as in U squared sine squared theta over 2g. So that's how we get the maximum height reached. Then from there, we shall be looking at how to get the time to reach maximum height. The time to reach maximum height. So, from the first equation, which says that V equals to U plus AT, but at maximum height, V is 0. And U is the y component of velocity, or the vertical component of velocity. Therefore, it is U sine theta minus gt, because A is negative g. So, when we make t the subject, we end up as t equaling to U sine theta over g, where U is the velocity and g is acceleration due to gravity. So t is the time taken to reach maximum height. But we also have time of flight, capital T. Now, for time of flight, this one is calculated after the body has landed onto the horizontal plane through the point of projection. So that means that when the body lands on the horizontal plane through the point of projection, the vertical displacement at that moment will be 0, because it is now having, since it lands on the horizontal plane, so it is at 0 meters above that, or it is on that plane, so it has no vertical displacement. So from the second equation, the SY, or the vertical displacement, which equals to UYT minus a half AT squared, the SY is 0, because during landing it is at 0 meters above the ground. So the SY is 0, A is negative g, and UY is U sine theta. So when we substitute in the second equation, we shall end up with 0 equaling to U sine t. But during that time of landing, as it lands down, that means that it will be having time of flight, because it goes up and comes down. So that time will be the time of flight, capital T. Therefore, when we make T the subject, we end up with the time of flight as the 2 sin theta over g. So you note that when we were looking for time to reach maximum height, that time was u sin theta over g. Yet the time of flight is twice u sin theta over g. So that concludes that the time of flight is twice the time taken to reach the maximum height. So that has been for now. Otherwise, I request you to please subscribe to all our YouTube channels. Go to homepage, scroll down, you find them. Please subscribe to them, hit the bell such that you don't miss out on any video. Otherwise, I'm teacher Ivan. I hope to see you in the next video. Please, we are still looking at projectiles, so please don't miss out the next lesson. Bye bye.